The determinant is a function on square matrices that tells us whether a matrix is invertible or not. If the determinant of a matrix is not 0, then A is invertible. If the determinant of the matrix is 0, then A is not invertible. Now, the definition of the determinant is a little bit complicated. Let's start with some small examples first. If we have a 1 by 1 matrix, now we can only take the determinant of a square matrix. So if there's only one entry in that matrix, then determinant is just that entry. For a 2 by 2 matrix, we've got entries A11, A12, A21, A22. The determinant is A11, A22 minus A12, A21. For n equals 3, A is the matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. And the determinant is A11, A22, A33 minus A11, A23, A32 minus A12, A21, A33 plus A12, A23, A31 plus A13, A21, A32 minus A13, A22, A31. Now this might look a little bit hard to memorize, but we can draw some pictures that will help. One thing you might notice is that every term in the determinant corresponds to choosing one entry of the matrix in such a way that we've got one entry from each row and one entry from each column. But we never have two entries in the same row or two entries in the same column. In the 2 by 2 picture, we've got this product of matrices, this product of entries and that product of entries. This one with a plus sign and that one with a minus sign. And the 3 by 3 pictures are there's 6 of them, one for each term. So we have this product and this product and this product and that product and that product and this one. These three have a plus sign and these three have a minus sign. And the way to remember is if we draw lines, the lines that go this way get positive signs. Now I realize that these 3 points aren't exactly on a line, but we sort of draw that and then pick up where it left off and continue. And then the lines that go this way have negative signs. So let's do an example with numbers. We want to take the determinant of the 2 by 2 matrix 1, 2, negative 3, negative 1. That's 1 times negative 1 minus 2 times negative 3. So that's negative 1 plus 6, which is 5. Since that determinant is non-zero, this matrix is invertible. And it turns out that if there are any fractions in the inverse, and there will be, they're going to have 5s in the denominator. So there might be 2/5, 3/5, negative 6/5. Because this determinant is 5, that's what the denominators are going to be in the inverse matrix. If we take the determinant of 1, 2, 2, 4, that's 1 times 4 minus 2 times 2, which is 4 minus 4, which is 0. So this matrix is not invertible. If we want to take the determinant of the matrix 1, 0, 1, 2, 3, negative 1, 2, 2, 3, that's going to be, we draw lines this way, 1 times 3 times 3 plus 0 times negative 1 times 2 plus 2 times 2 times 1, then minus the products that go this way, minus 1, 3, 2, minus negative 1, 2, 1, minus 0 times 2 times 3. So if we look at the non-zero terms here, we've got 9 plus 4 minus 6 plus 2 so that is 9 plus 6 is 15. Well, 9 plus 6 minus 6 is 9. So this matrix is invertible. And it's going to have 1/9 in the inverse. Now, if we want to take the determinant of a 4 by 4 matrix, we're going to need the actual definition. We can't just draw lines the way we did. So I need to explain a couple things to give you the actual definition of determinant. This involves permutations. And a permutation of 1 through n is a sequence P1 through Pn in which 1 through n all appear once. And there are n factorial of them, because there's n choices for what the first one's going to be, and then n minus 1 choices for what the second one's going to be, etc. So for example, when n equals 2, we have 1, 2, or 2, 1. Now, an inversion in a permutation is a pair of numbers that appear out of order. And that is the larger one first. So there's no inversions in 1, 2, but 2, 1 is an inversion, and 2, 1 because the 2 appears first and is larger. Let's let n of p be the number of inversions. So we've got 0 and 1. Let's let sigma p be negative 1 to the number of inversions. So sigma p is negative 1 to the 0th is 1, and negative 1 to the first is negative 1. Now the corresponding terms of the determinant are A11, A22, and negative A12, A21. So the first indices on the entries are always 1, 2 in that order. The second indices are named after permutations. So 1, 2, or 2, 1. And then the sign, this one comes with a positive sign, that one comes with a negative sign, comes from negative 1 to the number of inversions. So this is the determinant here, the 2 by 2 determinant. Let's do this with the 3 by 3 determinant also. So we have 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. The inversions are, well, there's no inversions here because those numbers are all in increasing order. 3, 2 is an inversion here. 2, 1 is an inversion there. Here we've got 2, 1 and 3, 1 because 2 comes before 1 and 3 comes before 1. Here we've got 3, 1 and 3, 2. Those because 3 comes before 1 and 3 comes before 2, and it's bigger than both. In 3, 2, 1, everything is out of order. So 3, 1 is an inversion, 3, 2 is an inversion, and 2, 1 is an inversion. So the number of inversions in these permutations are 0, 1, 1, 2, 2, and 3. The signs of these permutations, -1, so the number of inversions are 1, -1, -1, 1, 1, -1. So all we really care about is whether the number of inversions is odd or even. And we can call the permutation an odd permutation if it has an odd number of inversions, and an even permutation if it has an even number of inversions. So then the 6 terms of the determinant are A11, A22, A33, negative A11, A23, A32, negative A12, A21, A33, positive A12, A23, A31, positive A13, A21, A32, and negative A13, A22, A31. Alright, I don't want to write down all 24 terms for n equals 4, but we can still do an example, especially if the example has lots of zeros in it, because of course we don't need a product if the product is 0. So if we take the determinant of 0, 1, 0, 3, 2, 0, 0, 0, 0, 0, negative 2, 0, 0, negative 1, 0, 4, so we will not write all 24 terms, because most of them are going to be 0 anyway. Let's just think about which terms are not going to be 0. So since we need to take one entry from each row and one entry from each column, we have to take that 2. We have to take that -2, because each of them is the only non-zero entry in its row. And then in the first row we've got a choice of 1 or 3, and in the fourth row we've got a choice of -1 or 4. If we take the 1 above, then we can't take the -1 because that's in the same column. So we'll take the 4. And then the other choice is we could take the 3 up here, and then we have to take the -1 that's in the bottom, because we can't take the 4 because it's in the same column as the 3. Now the permutations defining these two pictures are 2, 1, 3, 4, and 4, 1, 3, 2. Just reading what column each x is in the various rows. And the number of inversions in 2, 1, 3, 4 is 1, because only the 2 and 1 are out of order. The number of inversions in 4, 1, 3, 2 is, let's see, 4 is bigger than everything and it comes before everything, so it's at least 3. And then 3 is bigger than 2 and comes before 2, so it's 4. So the determinant is, we'll have 1 times 2 times -2 times 4. And all of that with a minus sign, because -1 to the first power is negative. And then 3, 2, -2, -1. All of that comes with a positive sign. because negative 1 to the fourth is positive. So we have these negative signs cancel out. We've got 2 times 2 times 4, which is 4 times 4, which is 16. And then these negative sides cancel. We've got 3 times 2 times 2, which is 3 times 4, which is 12. And that equals 28. The end.